All right, here we go. Section 6.3 and 6.4 is pretty short section. You can see up here at the top, there's 5 slides. So it's pretty short, easy section. There's actually 2 sections together, and both of them are very short. So, and if you printed out the notes, remember when I check Unit 6, I want them taped or pasted or stapled into your spiral. And if you need a spiral, let me know. There's just a few things that you'll have to write down if you print it up. A couple of examples that we're going to fill in here. In section 6.3 and 6.4, they talk about quadrilateral angle sum theorem. And all that tells us is that all angles in a quadrilateral add up to 360 degrees. And we already knew that. We saw it on the chart. But it's a theorem that says if it's a quadrilateral, then the angles add up to 360 degrees, the interior angle. So you can look at this first quadrilateral right here at angle A, which is 90 degrees, plus angle B, which is another 90, plus C, which is another 90, plus D, which is another 90, and you have 90 times 4, and you get 360 degrees. You could also notice that you've got 2 triangles in there. Both triangles add up to 180, so 180 and 180 is 360. This is the same scenario right over here. You've got angle A, angle B, angle C, angle D, and they're all going to add up to 360. So let's look at example 1 down here and solve it. Give me an equation that would work. Okay, what would be a good equation? Here's my x, my 2x, so I'm going to take x plus 2x, and then I'm going to add the 70 and the 80 together, and that's going to add up to 360. All 4 angles, when you put them together, have to add up to 360. So let's just combine our like terms. 3x, and that's 150, equals 360. So I just combine the x with the 2x. I combine the 70 with the 80. And then I'm going to subtract 150 on both sides. So 3x equals 210. And I'm going to divide by 3. So how much is x going to equal in this case? 70. Now be careful, because in a problem they may ask you to plug it in and find a certain angle. Like if they said, what would this angle be down here at the bottom? If you put 2 sides 70, that'd be 140 degrees. Doesn't really look like 140 degree angle, but. All right, so there is slide 1. Again, if you don't have them printed and you don't want to copy all the diagrams, you can listen very closely, go back home later and get them. They'll be on the website. It'll be on a video you can watch and get the stuff down that you're missing if you need to. There's page 1. All right, page 2 is on all quadrilaterals. Now I want you to see this is kind of a thinking map, you might say, on what quadrilaterals are, on the different kinds. You've got 3 special quadrilaterals. You've got quadrilaterals up here that are not special quadrilaterals. That's a picture of one that's just a regular 4-sided figure. Nothing special about it. They're not the same angles, they're not the same sides, or anything like that. Then you've got 3 of them that are special. They have special characteristics. We've got kites, which are right here, which we'll talk about later. We've got a trapezoid, which is right here, which we'll also talk about later. Trapezoids we actually talk about quite a bit. And then we know, well, in the middle here it says polygon with 4 sides, and angles we know will always add up to 360. The third part of the quadrilaterals is parallelograms. That we're going to talk about now. That's going to be for the next few sections. We're going to be talking about parallelograms. Now, parallelograms, we know they have 4 sides. We know the angles add up to 360. We know they kind of look like this right here. But there are 3 special parallelograms. In the parallelogram section, there's a rectangle, which I made a little picture of. There's a square, and there's a rhombus. And each one has its own characteristics. But right now, I just want to talk about parallelograms only. That's what this arrow is right here for. So in this box, there's a few things that you need to write down. Characteristics of all parallelograms. This is what all parallelograms have. If it's a parallelogram, then it has to have opposite sides parallel. That's what the definition of a parallelogram is. Notice how it has the word parallel in parallelogram? So opposite sides have to be parallel for it to be a parallelogram. So that's our definition. So if you see arrows on the top and the bottom, and you see arrows on the two sides, then you know it's a parallelogram. You don't have to wonder if it is or not. If opposite sides are parallel, it has to be a parallelogram. The second one is opposite sides are congruent in every parallelogram. Does that mean all four sides are congruent? No, it just means top and bottom are equal, two sides are equal. If those two are equal to each other and those two are equal to each other, then you know you have a parallelogram. So it doesn't have to have all four sides congruent. It just has to have the top and the bottom congruent and the two sides congruent. The third one is that opposite angles are congruent. Does not mean they're all 90 degrees. It just means that the ones across from each other diagonally are congruent to each other. Notice right in this parallelogram that I wrote. See this one right here? This angle right here is going to be congruent to that one, where the diagonal would be. Those two angles are congruent, and these two angles are congruent. That's what opposite angles are congruent means. It means that the angles across from each other have to be equal to each other. If that's the case, then it has to be a parallelogram. And then the fourth one is that consecutive angles have to be supplementary. What that means is, let me draw a bigger parallelogram here for you, and you can see it. That means that this angle right here plus this angle right here has to add up to 180 degrees, supplementary. Consecutive angles. These two also would add up to 180. These two would add up to 180. These two would add up to 180. Any two angles in a row add up to 180 degrees. So any two angles in a row add up to 180 degrees. So any two, could be these first two, could be the top two, could be the next side two, could be the bottom two. They have to add up to 180 if they're next to each other. If they're across from each other, we know they're equal, because that was the previous one. But if they're next to each other, then they add up to 180. The last one is that the diagonals bisect each other. Again, let me draw another parallelogram. And let me draw in two diagonals. What does diagonals bisect each other mean? What does bisect mean? Cut in half. So that means one diagonal cuts the other diagonal in half, and vice versa. That means if you see this picture right here and it's a parallelogram, that means that this piece and this piece are equal. This piece and this piece are equal. The diagonals will cut each other in half. This point right here is the midpoint for both diagonals. That's what that means, if it's a parallelogram. This only works when it's a parallelogram. Now, you notice my little arrow right here and the word theorems? All four of these are theorems. This top one is a definition. The four bottom ones are theorems. So I could say an if-then statement. If it's a parallelogram, then opposite sides are congruent. If it's a parallelogram, opposite angles are congruent. If it's a parallelogram, then consecutive angles are supplementary. If it's a parallelogram, then diagonals bisect each other. Those are all theorems. They're all theorems that we could say in an if-then statement. We could make a conditional statement for all four of those. Good there? All right, let's move on. Let's do a couple of examples. Now that you know the characteristics of a parallelogram, let's see if we can find JH. Well, J to H is down here at the bottom. So what would JH equal? Do we have any idea? Has to be 5, because the top one and the bottom one have to be the same. So this is going to be a 5 right there. JK would be from here to here. Do we know what that is? It's got to be 4, because if this is 4, then this has to be 4. The diagonals bisect each other. They cut each other in half in every parallelogram. We know it's a parallelogram because these are parallel and these are parallel, so it has to be a parallelogram. That's the definition. If opposite sides are parallel, it's a parallelogram. What about angle Q over here? Angle Q is up here at the top. Is it 70 the same? Does it look like a acute angle up here? No, it's got to be 110. What do we know about angles that are next to each other? Got to equal 180. That's 110. What about angle R? That's got to be 70. Opposite angles are congruent. That's acute and that's acute. Those are the same. So here, diagonals bisect each other. That was this one. Opposite sides are congruent here. Consecutive angles are supplementary. That's why we got 110. Opposite angles are congruent. That's why we got 70 for R. So solve for X. What equation? I can tell you right now, I get a lot of students that want to make these two equal to each other. And they think they can solve it, divide by 3, and they get 40 degrees. Does this acute angle look the same as this obtuse angle? No, they have to add up to a certain number, which is?
360.
Not 360. 180. Now, if you wanted to make it add up to 360, you would have to do 3x plus 3x plus 120 plus 120. 120 and 120, 3x and 3x. That would add up to 360. But right now, we just know that consecutive angles are supplementary. They add up to 180. So subtract your 120 on both sides. So 3x equals 60. And divide by 3, you're going to get x is 20. So that would be your solution for that one. And again, anything that you're writing down into your book, if you don't want to print it, you just copy diagrams, get those down. You can always get more stuff later on it when it's uploaded.
Yep. So basically, if we had a parallelogram and they given us 2, we don't have to do the other.
We don't have to do all 4 in a parallelogram. No, you can just say these 2 are supplementary. If they gave me this one and this one, then I would know they're equal to each other because they're opposite angles. Okay, next one. Get it to work. Okay. A quadrilateral is a parallelogram if there really isn't any writing for you to do on this slide at all, unless you're copying stuff. Then you might want to just get it off the website later because there's a lot of, it's the same stuff. You actually don't need to rewrite this again, it's twice, but they do have another section where you have to prove that something's a parallelogram. For you to prove it, these have to be characteristics of the drawing, or at least one of them. If you can prove that opposite sides are parallel, then it has to be a parallelogram. If you can prove the opposite sides are congruent, it has to be a parallelogram. Just like for any of these, if you can prove any of these, then it's a parallelogram. A new theorem, one last theorem here, which you should have if you printed it. If you didn't print it, this is what you'd want to write down as the new theorem, is that a quadrilateral is a parallelogram if one pair of opposite sides is both congruent and parallel. So let's say I don't have this side here or this side over here. I don't have either of those two sides. But I know that the top and the bottom are both 9s. And I know that the top and bottom are both parallel. Then I can say without a shadow of doubt, yes, that has to be a parallelogram. The only way that they could be the same and be parallel is it's a parallelogram. That's the only way that could happen. So not only can we prove these, and now you have one more way to prove it's a parallelogram. You have one more way to show that, yeah, I know for sure that's a parallelogram. There is no shadow of a doubt that it has to be a parallelogram. Then the last slide is just seeing if we can prove it. Can we prove, do we have enough information to prove that these are parallelograms? So like I said, if you're copying it down, you'd probably want to just get that, maybe the picture. If you printed it, there really isn't much to write on the page. The last page, a quick example first. A quick practice problem from before. How do I solve this one right here?
Add
them all up and make them equal 360. Okay, so let's do that real quick. So we've got x plus 124 plus 110 plus 55, and it has to add up to 360. So let's see what we get. 124 and 110 would be 234, 289, I think. Check my math and make sure I got that.
Yep.
Is that 289? Okay, then subtract 289 on both sides. So x equals 360 minus 289. 1 and 7. 71 degrees. So x would be 71 degrees. That was just a little practice problem from before. All right, is there enough information to prove that each one is a parallelogram? How about this first one right here? Is that enough information? Because opposite sides are congruent. If opposite sides are congruent, it has to be yes. Yes, because opposite sides are congruent. Is this enough information to say, yes, I know that's a parallelogram? What was the reason on this one? Diagonals bisect each other. That has to be a parallelogram if that happens. If the diagonals are cutting each other in half, it's got to be a parallelogram. Is this enough information? Because consecutive angles are supplementary and opposite angles are congruent on that one. So consecutive angles are supplementary or opposite angles are congruent. You could actually use either one of them to prove that this one's a parallelogram. Because you see the opposite angles being equal and you see the consecutive angles being supplementary. What about this one? Is there enough information to say, yeah, that's a parallelogram?
No.
That one's no. Cannot prove that's a parallelogram. Your diagonal would not equal your sides in a parallelogram. Unless there's something special there. But normally that's not going to happen, and that's not enough information. You need opposite sides congruent, or you would also need these to be parallel to each other. But they didn't give you. What about the last one? You got, these are both 6 and they're congruent, all right, and they're parallel. If they're congruent and parallel, does that make it a parallelogram? Yes, that was the new theorem. If one pair of opposite sides are both congruent and parallel, then it is definitely a parallelogram. All right, there are your 6.3 and 6.4 notes. That's all we have for those. Pretty short, like I said.